Okay, guys, in this video, we are going to take a look at applications of line integrals to computing work of a force. So the force is given as x, 12xy, and negative x plus z in parentheses. And it is acting on the particle to move it from point 1, 2, 3 to point with coordinates z, 0, 3, 2. Now, the first thing you have to do, and everybody has to know that, is how to make a parameterization for a line segment. So that is actually very easy, but you need to practice. First, we are going to start with the point where the line segment starts. So that would be 1, 2, 3, and we just put 1, 2, 3, just like that. Then it's going to be plus something t, plus something t. Now remember that the something here has to be a number. So you're talking about a line segment, you never put anything other than a number in there. Now what number? A very common mistake is to say that the numbers that go in there would be 0, 3, 2, but that's not correct because you want this line segment under certain values of t to be equal to 1, 2, 3, this parameterization, and under another value of t to be equal to 0, 3, 2. And so what do? What you do is you compute the difference between 1, 2, 3 and 0, 3, 2. So you subtract. So 0 minus 1, and you always do the second point minus first. So there will be 0 minus 1, which is going to be negative 1. This is actually going to give you a vector of direction of this line segment. Okay, that because it connects one point to another point. So what I'm doing is subtracting, so that this vector is going to be like 0 minus 1. That's going to be the first component. Then there'll be 3 minus 2, and then it's going to be 2 minus 3. So this is going to become 1, so that goes in here, and this will become negative 1, that goes in here. Now, to check that out, let me just make this a little bit prettier. So this would be 1 minus t, this will be 2 plus t, and this would be 3 minus t. To check that out, we also need to know that this specific parameterization is always going to be where t goes between 0 and 1. How do I know this is true? So if I were to substitute t equals 0 into the parameterization, I get 1, 2, 3. So I know that my line segment starts at 1, 2, 3. Now, if I substitute t equal 1, I should get the second point. So t equal 1 will give me 0, 3, and 2. So I know that this parameterization is correct. So let's just see if we can type that in here. So this will be 1 minus t. This will be 2 plus t. And then this is 3 minus t. And again, t changes between 0 and 1. Okay, once we get the parameterization, how are we going to compute the integral? So this is work integral. What do I mean by work? So the special work integral looks like this. So this would be force dot dr. And this dot is really the dot product. So how do we compute something like this? Well, just think about it. It's not really that complicated. So you take the force, and so that will become x 12xy, and then negative x minus z. I'm going to distribute that minus, and I will dot that with dr. Well, what the heck is dr? Dr is going to be x prime, y prime, z prime. So this is like dx, dy, dz. Okay, and this of course is still an integral. So okay, so when you compute the dot product, this will just become first component of the force dx plus second component of the force dy plus third component of the force dz. Okay, now what is what here? So let's convert this to a regular dt integral. So first, we're using the parameterization we just found in part A. So the limits are going to be from 0 to 1. Then instead of x, we are plugging in what we get from the parameterization. So that's 1 minus t. Instead of dx, think derivative of x. So what is derivative of x when x is 1 minus t? Well, that would be negative 1. Okay, plus. Then it'll be 12x, that's 1 minus t, y, that's 2 plus t, dy. Again, what's dy? Derivative of y. Lucky for us, that's just 1. So this is just going to be 1. Okay, so then plus, we got minus x, so this will be minus 1 plus t, minus z. That would be subtract z, so that would be subtract 3, but add t, right? Because we are subtracting. Okay, and then the whole thing is going to be dt. So we have a lot of terms here that we are going to simplify. So we can't leave it like that. Never try to start integration until you completely simplified and combine like terms and all that fun stuff, okay? Can't say that that's the fun stuff for me, but you know, you gotta do what you gotta do. So this is negative 1 plus t. All right, so here let's FOIL this. So this will become 2, so that's 24. Now this becomes plus t minus 2t, so that's minus t. So this will be minus 12t. And then finally, t squared, negative t squared. Okay. Then over here, let's simplify that. That's minus 4 plus 2t. Okay, let's see if we can combine like terms. So what do we see? We do see t squared, and it is by itself. So it's lonely, there is nobody there, negative 12t squared. Okay, what else do we have? We got a whole bunch of t's. So we got t, we got minus 12t, and we got plus 2t. So that's negative 10 plus 1, negative 9. And finally, the numbers. So what do we have with the numbers? We got negative 1 plus 24 and minus 4. So that's 20 minus 1, that's plus 19. Okay, so I forgot to multiply this by z prime or dz. So that's a negative 1 right here. So that's not going to be good. So this is plus 4. And then that's negative 2t. So how is that going to change my answer? Ay, ay, ay. Okay, so this is plus t minus, that's 12t, that's minus 11t minus 2. So I got minus 13t. Does that look better to you? I don't know. 28 minus 1, 27. Okay, let's try this again. And if this doesn't work, I will quit being a math teacher and switch to Zumba. No, it does work. Okay, yay. All right, so then let's integrate. So this will become t cubed over 3. This becomes t squared over 2. And then this becomes t. Okay, substitute 0, 1. Now that part, I don't think I can mess up here. So this will be negative 4 minus 13 over 2 plus 27. 33 over 2. Okay.